Okay, I was asked to help with number 20, so that's what we're going to do. So we're doing number 20 right here, where we're combining these two solutions, two different masses. It tells us the temperature change that we have, gives us the heat capacity, and the number of moles of the limiting reactant in this process. And we're looking for the enthalpy. Okay, so I wrote this down, the gist of it over here. Okay, so that's all the information we need. And so what we're basically gonna use is we're looking for enthalpy. So enthalpy, remember this is a chapter 4, I think. Chapter 4 question. So you have to go back and check that. So if we remember from chapter 4, we had that Q, the enthalpy of the reaction is equal to the Q of the reaction over the number of mole N. And this N is the moles of limiting reactant, right? And that's what we got right here. So we already got that. So we already got N, so that's a check. So we just need to figure out Q. Okay. So, okay, Q. So to get this Q, we need the Q of the solution. So we're going to get Q of the solution, and we're going to get that by doing our SM delta T, right? Okay. So S, they give it to us right here, 3.98. So that's good. 3.98 joules, grams, degrees Celsius. Okay, our mass. So we have two 50-gram samples. So our mass is 50 times 2, which is 100. So we got 100 grams of our solution, 100 grams. Okay, delta T. So here it's going to be final minus initial, this 22.32 minus this 20. So that's just 2.32. Quick math, 2.32 degrees Celsius. Okay, so we can get the Q of the solution by just doing some math right here. Okay, so we get 923.36 joules, right? Joules, grams goes away, Celsius goes away, right? So we're left with just joules. Okay, it's important distinction here that I said Q of the solution, right? Not the Q of the reaction. So again, go back and check. So we're taking right here, we have our solution out here, and right here, that's our reaction, right? So any heat that comes from this reaction, if I get some heat from this reaction, is going to go into my solution. So that's why I figured out my Q of the solution, because again, go back to chapter 4, you see that Q of the solution equal to negative Q of the reaction. Okay, so that means that Q of the reaction equals our 923.36 joules, right? Right, can't forget, don't assume that this one is the Q of the reaction that we're solving for. We had to, oh, forgot my negative sign. So it's negative that, right? Negative, I need a negative sign. Okay, so now that we have that, we can get our enthalpy, okay? So we go back, so now we plug it into this, so delta H equals my Q of the reaction, which is negative 923.36 joules over my 0.00500 moles. So that's going to be almost did it wrong. They'll do 3 sig figs. Yeah, that one has 3. So we'll do 185,000 joules. So delta H, put that in, well, it's joules per mole technically. So we'll say delta H is 185 kilojoules per mole. That'll be negative, right? Forgot my negative sign, almost bad. So okay, I go look for this answer in the, I think, negative 185 kilojoules per mole. And if we go back, we see that that is answer choice D.